The what? That. Well, how does an angle tell you a side? I'm looking for a specific proofy type reason here. Oh, that is a good buzzword. That's not what I'm looking for. There are vertical angles. However, these vertical angles aren't really relevant to our picture because we're looking at the big triangle, and these are angles of the small triangle. How can I prove this? What pieces do I need to know? I can tell you when they overlap, right? The reflexive property of congruence states, that's right, RPOC, states that FG is the same for both. FG is congruent to FG by RPOC, the reflexive property of congruence. Now, there was another thing I told you last week. I said if it ever tells you two angles in a triangle are congruent, what you do is automatically throw in there. If it tells you the two angles are congruent, what do you immediately know? That the third angle is congruent. So anytime it gives you two angles, and we're doing more of this stuff today, so you guys need to rev up your brain, then you should always also start. So we have the reflexive property of congruence. We have the third angles theorem, which lets us know that these angles are also congruent to each other. Now, we have a side and we have all of our angles. So what do we use to wrap this thing up? No, we've only got one side. Angle, side, angle. Angle, side, angle. This! I hope this is the kind of stuff you put on there Friday, because this is what it's going to take to be correct, and it is being done for accuracy. So, and that's the kind of thing I'm going to need from you today. RPOC, third angle theorem, angle, side, angle. And you may be thinking, Mr. Crawford, we've done this for like 3 straight days now. Here's the little twist for today. Instead of me saying, prove the triangles are congruent, here's what I'm going to be asking you today. I'm going to say, prove not that the triangles are congruent. How would you explain to me the proof for how FK is congruent to GH? Well, even if they were parallel, which actually you could prove, that doesn't say anything about them being congruent to each other. And here's how you're going to do it. Somebody raise your hand and tell Lena, what does it mean for two shapes to be congruent to each other? Exactly. They have the exact same sides and angles. So, what you're going to do today is, you're going to prove that the shapes are congruent, like this. And then once you've shown they're congruent, you can show that any of their pieces are congruent, because the definition of congruency is that all of their sides and all of their angles are congruent. So this is the one piece of notes you have today. And we're going to call this CPOC, corresponding parts of congruent triangles. Corresponding parts of congruent triangles. That's what those paragraphs say. You're going to use this like crazy in proof. CPOC. If you can show that the triangles are congruent, then you can tell that their corresponding parts are congruent. Every single problem you have today, assuming you can prove that they're congruent, is going to end with CPOC. If you're going to end with saying, by using the corresponding parts of congruent triangles, I can say that all these pieces are also congruent. And it's the only piece of notes for today. That's why I said you have a nice meeting today. It's the only one. And we'll look at 1 or 2 examples, and I'm setting you up. Don't stare into the abyss, folks. Put that in your notes. By definition, if shapes are congruent, then their pieces have to be congruent. So if we show that triangles are congruent, then we can just turn right around and say, well, then their pieces have to be congruent. So our goal today is to show those triangles are congruent, and then use CPOC, the corresponding parts of congruent triangles thing, to say that their pieces are congruent. Okay. Let's look at some examples. Okay. Here we go. Let's look at these examples, for instance. We have to show that these pieces, number one, we have to show that these two pieces are congruent. But we can't do that until we show the triangles are congruent. So, Elon, how many pieces, now look, these are two individual triangles. How many pieces do I have that it's telling me anything about per triangle? That's right. And we're looking to show that those are congruent. How many pieces did it tell me about each individual triangle? How many things have a dash or a loop through them in just one triangle? That's right. And then one side apiece, right? So that's two things. It's giving me one angle and one side. How many things at minimum do you have to know to show the triangles are congruent? 3. Where's the third one? Sage. Thank you. The reflexive property of congruence. Remember, if two shapes are right on top of each other, you can use arpoc to show that that common side is obviously the same for both. So this one, you would start out with arpoc. Step 2. How could I then show that triangles are congruent? Sage, you just get this stuff. Side, angle, side, side, angle, side, side, angle, side. Now, the last step today for every single one of these is going to be, then how do you turn around and show that these pieces are congruent? By using CPOC, the corresponding parts of congruent triangles. You've shown that the triangles are congruent, so you can use CPOC to show that their corresponding parts are congruent. That's where that acronym comes from. Once you've shown the triangles are congruent, you can use CPOC to say all their pieces are congruent. Therefore, this piece has to be equal to this piece, which is what this was asking us to say. Number 2. Starla. How many pieces did it give us in number 2? Per triangle. And that little arrow doesn't count. Put your fingers down. In each, we're looking to show these two triangles are congruent first, right? So, in each triangle individually, how many pieces do they give you to work with that they are already telling you are congruent? I'm sorry? You're right, but I'm asking you something easier than that. Let's cover up that bottom triangle for a second. Ah, dang it, hold on. How many pieces in that top triangle have a line or a loop through them, not including that arrow? This one and this one, right? So just 2. Only 2. Now, how many pieces do you know to show the triangles are congruent? 3. So we have to find the third one. Trip! I told you guys that whenever you have parallel lines, what is that going to be a red flag for? Anybody remember? Yes. What? No. If they give you parallel lines, every single time it's going to be a hint that you're going to be looking for some of those transversal angle properties. Do we have any of those transversal angles in this picture? PQT. Well, actually, there's 3 angles there, so you can't just assume that they cut in half. But we have parallel lines. What kind of angles that were formed by parallel lines? Alternate interior, alternate exterior, corresponding, consecutive. Which of those appear in this picture in a way that is helpful? Very good. Which 2 angles are corresponding, Donovan? You have to give them the 3-letter names. R could be this angle, could be this angle, could be this angle. So T, there's not too many T's. Which angle is T congruent with? The top R. The top R. Wouldn't that just be this if you were looking at it on a full thing? Corresponding angles. And the corresponding angles postulate tells us if you know that lines are parallel, which we do, then corresponding angles are congruent. Now, what could you use to solve this proof? What's that? There is no angle.
Oh.
First off, corresponding angles postulate, what? You can't use CPOC to say that triangles are congruent. You have to name that they're congruent first. What? Almost. Almost is the side we have between our angles? No, but what should you always just sprinkle in there? Once you know the two angles are congruent, the third angles theorem. Once you know that two angles are congruent, you immediately know the third is congruent by the third angles theorem. Now you can use angle side angle. Or you could have used angle angle side, but I like to just always throw that third angle in there. Now, back to Tripp. Now what are we going to use to show these pieces are congruent? Say it again. CPOC. Once you've shown they're congruent. So, before you can use CPOC every time, you are going to have to use side angle side, or angle side angle, or side side side, or hypotenuse-like congruence theorem. Those are the only things I've given you that you can do that with. I've only got one more example. Are there questions on what you're going to be asked to do? Okay. The last example, half of them on your paper. Half of them on your paper aren't going to be labeled. So I'm telling you right now, label all your vertices. As soon as you see this problem, you should be like, oh, well, I'm just going to call this A. I don't care what you label it. I'm going to call this A, B, C, D, and E. Every major corner needs a name. Once you've done that, hold on one second. Now, also, the ones I made for your worksheet today, those are not going to have like specific pieces that it's asking you to tell it congruent. What I want you to do is prove the triangles are congruent and then name for me all the missing pieces that you can do with CPOC. For example, on this last one, instead of just writing CPOC when you were done, I would need you to say, so that allows me to know that RQ is congruent to TS and PQ is congruent to RS. I want you to name the other things you know are congruent. So that would be PQ is congruent to RS, and TS is congruent to RQ. That's the kind of thing I need you to do once you've shown the triangles are congruent. Name the pieces that you can now assume are congruent. Does that make any sense? Now, another thing I pulled out this example for is, what's the problem with this one? You don't have any sides. And if you don't have any sides, what can't you do? You can't prove they're congruent. There are 2 in your homework today. There are 10 total. 2 of them you can't prove. So you just put can't prove next to them. And this is one of them. So you really only got one other one. There are 2 of them that you can't prove. So really you only have to do 8 problems today. And the last 2 you just can't prove. It's up to you to find what 2 those are. Are there questions about what you're going to be asked to do? Prove the triangles are congruent, and then say all the pieces that they have are congruent. Okay. I'm going to pass these out.